Glad to be here today. I gave this talk, I think, in 3 languages already, so it's for my first time doing it in Python. It was fun for me. I hope it will be fun for you. So we're going to talk about today how to TDD a REST API. A lot of letters over there, and I'm going to explain what TDD is. REST is what this guy is doing. It's also a sort of architecture that you might have heard about if you develop some kind of APIs. And what I'm going to show you today, how in itty bitty little steps, something like 20, you can build an API doing it the TDD way. And I'm going to explain that and why it's important to learn what are the differences in regular test-driven development. And if you're new to test-driven development, I'm going to show you what it is. So, who am I? So my name is Gil. I come to you from Israel. I'm a consultant, I'm a trainer, and I teach and work with a lot of people, developers, testers, anyone around software who wants to create better software. I'm working people on test automation, TDD, clean code, unit testing, anything that is related to how to create better software. I'm also the author of 2 books, Everyday Unit Testing and Everyday Spring Testing. That's for the Java people. And you can get in touch with me in email, testinggil.com, or on Twitter, where I rent a space there. Right, so yeah. So I'm going to start at the beginning and where this actually, this session came from. These guys. So I teach a lot of people the TDD, test-driven development, and when you look at examples of test-driven development, you'll see like calculator examples like I'm going to show you in a few seconds. And it looks easy. And there's a very big gap in what you're seeing on the screen and saying, well, this doesn't look like my code. How will it work? So I'm here to tell you that it may not be easy, but you can take it to other stuff rather than just unit testing, stuff like that. And today we're going to talk about how to build APIs in this way and the principles behind it. So if you've worked and looked up some things about TDD, you might have seen this kind of picture before. It looks like a circle. It's called the red-green refactor circle. And why is that? Basically, TDD is an iterative process where you write a test and it fails. That's the red part. Then you write the code that passes that test and make it green. Asterisk, not just this test. All the tests that you've written until now still need to work. So that's good. You have a passing test or passing tests, and then you refactor the code and the tests because you know that it is working. And the separation between make things work and make things readable and maintainable works very well. And it comes from the unit testing world. JUnit, I think it's the first test framework in Java, was written to write unit tests. But other than that, test frameworks have been like extended to work with anything like we're going to do today. So I'm going to show you a couple of slides. They are in Java, I know, but before we jump into Python, I think you'll be able to like look at 3 things that are okay. So this is a test. You can see that if you write a test, a calculator test, of course, you see that you get some squiggly lines under calculator. And the reason is that because we're writing the test before there is no code. So there is no calculator class at this point. And in order to do that, that's the red part. Then what we do, go to the green part is write some code. And then we have a calculator and the method add and the logic that passes the test. And basically what you have right now is the green part. You have test that passes. But then that's not enough. Instead of I and J, I would refactor those and rename them to something that makes more sense, to have first number and second number. And this is basically a cycle that goes on and on and on. And like I said, when you look at this kind of thing and you said, I'm developing APIs, how does that work in the real world? Does it work the same? The answer is not exactly, because you might look at it and say, well, it may be easy on paper, but it might be one of the hardest things to do. So I'm going to show you that it's not that hard, but there are things that happen in the real world that are a bit different. And the reason they are different is that in the unit testing world, we kind of look at the logic that we have and nothing else. So it's easy to have this kind of cycle. And this cycle usually takes like, I don't know, 10 minutes, 15 minutes for a test to pass. So you go very quickly. But when we're talking about APIs, anything that has all kinds of dependencies, real world start to sink in. So for example, if you develop APIs, you know that in order to make a test for an API pass, you have to write quite a bit of code. It's not just the logic. It's the server itself, maybe the database, some data in the database to call and retrieve and stuff like that. So the 15-minute cycle doesn't really happen. And that has a very big psychological effect for people who's doing TDD for a while. They don't have any patience. They don't like to wait until they get this kind of feedback. So in order to pass, first of all, I need to have like a big setup. And that's just to pass the first test. Like then I'm moving to another one, and I need to have a big setup for that as well. And I have to wait a long time between passing tests, like the development time. So this kind of like pulls people out of the cycle. Another thing is that once we're out of logic world, we have all kinds of dependencies that we kind of need to integrate with, and frameworks. I'm going to show you the example today with Flask as my platform, and it doesn't do a lot of things. You don't have to have a lot of code around there, but you can, and you need, like in the small examples I'm going to show you today, just retrieving query parameters or the body, something that is platform code, which doesn't look like much, but it kind of adds up. And all these kind of dependencies, we kind of like get stuck. I know I got stuck on a couple of things there, not just because of familiarity, but things don't work because other things in the environment just don't work or are not set up correctly. So the whole cycle of red-green refactor is kind of broken. But like I said, we're here to learn how to do this anyway, even if it looks broken. So we need to, first of all, like match expectations and understand what we're going to do. And if we want to expect something, it might be better than Spanish Inquisition. So what are we going to expect? Well, the first thing is that if you've done TDD before on a unit test level, it's not going to be as smooth as that. So the cycle, like I said, going to be a bit bumpy, and that's okay. So once we understand that this is how it's going to work, it feels a bit better. Second thing, it's true also for the developing just logic in unit testing. It's going to be a bit more rounds of until you get it right. We sometimes call, not sometimes, TDD is not just a development method, it's a design method. So we can design the code as we're doing. And we're going to design a couple of things today as part of our journey there. And we don't always get it the first time. I'm going to show you in my very short 20-step examples the length that I did when it's not like a straight, like this is how you do it, but the journey itself and what kind of things I was thinking, what the test showed me, and I decided to change away. So it's going to be like a couple of rounds. We're going to refactor a lot. We're going to do small steps, and therefore we're going to do small refactoring steps, which are easier and less dangerous. So it's going to be quite safe, and we'll have our tests to help us. But there's going to be some refactoring all the way. It's not something that we keep to the end. The one thing that is a bit different than regular TDD is that in regular TDD, when you're done, you're done. Yeah, you've gone through the cycle, you test code, test code, test code, test code, you're done, because the tests prove that everything works. Not true in integrated tests or API tests today. We probably want to extend what we have and what we've developed with more tests to help prove or confirm a confidence that this is actually working. And after we develop what we're going to do today, I'm going to show you what I mean in our example. So how are we going to do this? So I'm going to set up a couple of rules because I do this kind of presentation. So what are these rules? First of all, there's some kind of thing or architecture that we're going to follow. So you might have seen this kind of architecture before. They're from the 90s or 80s, maybe even before. It's called hexagonal architecture or ports and adapters. Basically, it tells you like there's what you're developing, your core application is basically the blue stuff, the business logic, and it needs to be talking to the other things on the world. On the right, you have like the database or queues or whatever other services, and your service may call other services, of course. And on the left hand, you'll see that other things are calling the R APIs. So this could be UI, console, or test scripts, or whatever. So hexagonal architecture tells you that keep the logic in there as much as you can. And whenever you need to talk with the external application, you do this through adapters, like very other interfaces or classes that kind of rep or talk to the other things for you, not directly in your code. And the reason to do that is that once you do that, it's easier to develop, it's easier to maintain and understand, and it's easier to mock or replace the adapters with other stuff. So if we follow this kind of architecture, it will be easier for us, obviously in the long term, but also in kind of development. To do that, we're actually going to go through in this example to look at something like that. So what are design rules? So we're going to use adapters for things that we can't control, and this example will show something that we can't control. One of the things that we probably want is thin adapters without any logic in them. We can have adapters that are like fat or something with logic in them, but usually what that means, we need to test adapters as well. We probably don't want to do that. We'd like to do is keep our tests on the logic itself. So whenever we're going to talk to something else, going to be a thin adapter there. We'll try to have a logic talk with our own domain data models, and we'd like to our test to participate in that language as well. It makes for better and readable code. We're going to do very small steps. You'll see that small steps. When I do that, I actually commit after a very small step, and you'll see what actually small means. We're going to refactor all the time. Like I said, we're going to abstract framework code. This means when we're going to read something like a function or a method, it's going to be reading like the same language. And I need to like issue something like another request, going to be needed in another function or another module. We'll see that as well. Final thing that I'm not going to show you today, but you're probably going to experience is how to delay framework code integration. That means that it's very, we have an incentive to connect everything together. So we'll see that it's working, but we'll see that there is code that I'd rather push for later and move on with my cycle so I can actually move forward and develop stuff. The application I'm going to develop, it's not going to be a full application, but the application that I'm going to develop is called the Navigator. So what I'm going to do basically is create APIs for Navigator applications. And what these APIs can do is that the user, I'm giving you the requirements before I'm doing anything in terms of specs. User can set a destination, drive there, and then the user can ask the distance between the current location and the destinations in kilometers. Why I do that? Because that would be really our logic. We're going to sort of use a separate third-party service, our dependency, really, which retrieves the distance in miles. So our logic would be to call this service, get the things in miles, and once it does, we're going to translate that into kilometers. That would be our logic. Right. So how are we going to do this? With a cunning plan, of course. So a couple of rules, apart from the architecture. I'm going to assume, because I did this, we kind of have whatever we can think of in terms of the code. Okay, so I chose like Python 3.10, and we're going to use Flask as a service, and I'm using unit test as the framework, but you can obviously do PyTest or whatever, and I'm using PyHamcrest for the assertions. You can do whatever you want, but this is my my rules. Why? Because I've decided, and basically Stone Cold says so. So we're going to do that. What else am I going to tell you before we go into the code is that if we take the hexagonal architecture to our application, basically the Navigator is going to be the blue stuff. And we have the Navigator controller. This is basically the Flask container who's going to expose the APIs. And there's going to be an adapter on the right, which will help us call the distance service. And that's basically, this is what we're going to develop, the things in the middle. And that's a bit of the slide. So we're going to switch to PyCharm. And as you can see, these are all the steps I'm going to show you. I'm starting off with nothing. So usually when you're going to develop that, you're not going to have a folder for each step. You're going to do the steps on the files themselves, but I'm keeping it like every folder its own little world. And you're probably going to see that. I'm starting out though with nothing. So all I have is a test file that does nothing. That's the default PyCharm thing. Nothing. First thing I'm going to do is I'm going to write an empty API test. How does it look like? So I renamed the thing to Navigator API tests. And I have two tests. The first thing is test navigate to the same location. The distance is 0. How does it look like? Well, I'm creating a location class. It's like this. Nothing in it. And I'm initializing it with cd name. And I'm calling set start point, set destination. And I'm checking the distance to destination equals 0. Now, remember, I mentioned that we're going to have like every method talking in its own language. This is the domain language. If you look at the bottom, you see that all the details of that are not there yet. And that's cool, because I'm writing things in terms of intention. This is what I want to do. This is what I want in terms of behavior, the APIs to behave on. Second thing I want to do is to test that the navigation and drive to another location, assuming that I'm getting closer, the distance is reduced. So I'm creating initial location, basically in New York, setting a start point for initial location, and create another location which is the destination, which is Los Angeles. So I'm traveling west, and I call distance to destination to get the initial distance to keep it. And then I'm setting a mid location, and I'm going to drive to that location. And then I'm going to check that distance to destination, the current one, is less than the initial one. Now, if you look at it, you say, well, what kind of a test is it? So this is a kind of a behavioral test. If I worked with real numbers here, assuming that at one point I'm going to connect to the real service, that might not be exact or something like that. But a behavioral test says, well, this is the behavior that I'd like to see. Calling this kind of scenarios, these APIs one by one as a sequence, I'm expecting to see this kind of behavior that the distance gets reduced. Like I said, at this point, I didn't put any implementation in there. I just want to see that this makes sense to me. And this would be the first. If it doesn't make sense in terms of API, basically what we designed here is not even the APIs themselves, but how we're going to call them. But if I can't read this and I don't understand, it doesn't make sense to me, I can stop here to rewrite it. So that's first step, empty API test. The next would be to add some implementation, this to call the controller. So this is the next one. Tests remain the same, but I filled in the things here. How do I do that? So I created a navigation controller. That's the Flask thing. Nothing in it completely. I've created for every API this method I'm calling the using a Flask test client. Create it here. So it runs internally, same process, just for the tests. Cool thing about Flask. And I'm just saying post, and I'm deciding this is a post thing. Remember, it's not there yet, but I'm designing the APIs. So /nav/start point, and I'm going to send a JSON. And what I'm going to do is basically take the location that I'm sending and send it content, like serialization of data. Basically, the location doesn't have anything in it. We didn't move yet. So that's for the start point. This is also for the destination, works the same way. The distance to destination goes to a get method called navDistance and checks that we get 200, of course, and it takes the JSON that's returned in the body, and I'm putting it into a distance object. It's a new thing here. Going to use this distance also as a class, a data class in the server as well, if possible. Like I said, we're trying to do this. So locations and distance, I'm going to try to use this the same way. However, what I'm going to do is have this thing called here, because I have what I'm returning to my test is basically the thing in kilometers. So what's returned is something that I first want to see that it works. So far, so good. I have an API test, no APIs yet, right? If I run this thing, it fails on a 404. Yeah, doesn't exist yet. So the next thing to do is I'm keeping the APIs the same, but I'm setting up the routes so I can actually call them. So now if I run this test again, this time I'm getting a 500 thing. So that's a logic inside the controller that fails. Obviously, there's nothing in there, but we get to the controller. So our tests now work. They don't pass, but they work. They call the controller. They don't return anything. We'll get back in a minute. But now that I have done this, I can move forward to the logic. And that means writing a unit test. So I'm skipping I have API test that I'm okay with. And I'm going to go to the unit test level. And I'm going to start developing the logic with test-driven development, which means the first thing I need to do is write a unit test. So that's another file. And the first test I'm writing is throwing or navigating without a starter point. So if I'm creating a navigator, and again, there is no navigator. just this. Whatever it needs from here. So that means an initializer, constructor, and a method called getDistance. So what I'm expecting is that if I'm starting something and calling, creating a navigator and calling getDistance from destination, I'm expecting to throw an exception. Why? I design it that way. I decide that when this happens, this is the behavior I want to see. But then I said, well, why do I do that? Why do I allow creating a navigator without a starting point? If I create a navigator with a starting point, then I wouldn't need to worry about exceptions. So I threw this away and I created a new unit test. And remember, there's no logic there, so I can throw away stuff. That's the cool thing about TDD. If you work in very small things, throwing away is not a problem. It's not like you're throwing 3 days of code. This would be like 10 minutes. Right, so I said, I'm not going to do that. So what behavior am I going to check? So this is when created, the distance is always 0. So creating a location, passing it to the navigator and asking what the distance from destination, since I didn't set anything on the destination. I want the distance in kilometer to equal 0. So basically that's it. Although navigator, the only thing that I would need in order for it to run and not crash completely is return a distance. And I've distance now basically gets the miles. Remember, it doesn't do anything. This returns -1 for the reason that this is going. I need to see that when I'm fixing it, it will actually work. So I have a unit test I really like. So let's pass it. And obviously, if this was -1, passing it is very simple. I'm going to return 0. So now I have a unit test that works. Excellent, ready to be shipped. Well, not really. Next test. Next test is like this. Remember, TDD, we're not doing anything to the logic without adding tests and making sure that they work. So the first one's okay. Second one, it's a bit different. So I want to check that the distance is calculated in kilometer. This is our logic, right? So the case I'm testing is that if it's going to be 2,500 miles, it's going to be translated into 4,000 kilometers. What does the test look like? Well, starting point is a location in New York, creating the navigator with that starting point, with the location, setting a destination, Los Angeles, set a destination. This is a new method on navigator, but it's not implemented yet. And then I'm calling get distance from destination and expect the distance kilometer to be 4,000. Excellent. There's a problem here. And this is something like happens a lot in TDD. You look at the test and say, well, something's missing here. I know what's missing here. Remember when I told you we're going to use a separate service, right? A third-party service. How is it going to get into the navigator? So this thing either will work with fully integrated with that service, or I'll need to inject it and change the navigator constructor to get something else. Now, I can do that, but I don't want to do it on a failing test. So what I'm going to do, step by step, very itty-bitty steps, is I'm going to put this test, which I like, that's the behavior that I want, but I'm going to put it in comments and then a couple of steps to modify the navigator, make sure it keeps working and passing the first test, and then go back to the second test. So how does it look like? I put this in comment, not to forget, so I won't forget what's happening here. And I'm this time I'm changing it. So like I said, there's going to be some kind of an adapter. Remember, we talked about adapters that contain and abstract the service, and I'm going to pass it to the navigator. So that's cool. I modified the navigator signature, and I'm calling self. I'm still keeping that in the variable, and I haven't touched anything other than that. So this test still passes. Okay, cool. Still passes. I can still do things. What else? I want to do something a bit before I move to the second thing. I want to look at this. So our navigator now has a distance provider, but it returns distance from here. So what I want to do, and it will happen later on, is obviously what will happen is that the distance provider is going to return the distance. So I'm going to push this implementation into the distance provider. So and it's okay. It's just moving the logic of the method in there, and my test should still work. So same test, but this time I'm calling the distance provider get distance method. I added this method. So look at that I'm sending starting point and starting point. It will come in later in our story. I don't have to do that, but I'm guessing that my get distance here will have a start and a destination. And I just pushed this here. It doesn't matter what I'm sending here. So is my test still running? Should. Excellent. So this thing works, and I pushed the implementation of the distance there, but really what I want to do is mock the call to the distance adapter, because when a real service will be there, I'm going to return what I want to do that in the unit test. So I do that in the test itself. So I'm saying this provider, I'm using patch unit test mocking mechanism, patch the distance adapter, and when get distance gets called, return distance 0. So now it doesn't matter what happens in the distance provider, the mocking will take place anyway, and this will return. Again, it's equivalent, very small steps, but now what I've got is something that I can copy or mutate to the second test. I can rewrite the second test in the same language. So I'm going to re-add the second test, and it looks like this. It's going to have another mocking, only this time returning a distance 2500, and everything looks okay, same as before. So I'm going to run it, and it should fail. Why should it fail? Because I'm expecting 4000, and what happens is that it returns 0, the distance 0, remember? So need to have some kind of logic to not return 0. Where is that? So it returns 0 because kilometers return 0. So this is where we put in our code. So in order to do that, in order to pass the unit test, distance will now have the conversion from miles to kilometers like this. It's an integer. So this is the main logic of our application, right? So that's cool. I have 2 tests passing. Let me prove it to you. But like I said, we need to refactor that. There's repetition. There's this thing here that repeats itself, and the mocking sometimes like this and sometimes this. So let's do a bit of tweaking to the refactoring, to the test code. So let's look at it. So basically, I created the setup method that created the patch on the distance adapter. That's the common code that runs before every test. And I created the method called setDistance to make it more readable. What is it more readable? Remember, we wanted the same language inside the method, and the mocking thing here is kind of a different language than the rest of the code here. So separate that into a different method or function, and that's cool. That's basically it. These tests are still passing. Are we ready to integrate? Well, not completely. Remember that we have this thing here in the navigator with sending something that will always come up. It doesn't really make sense, right? We want to actually set a destination and use that. How do we do that? Cool thing about TDD is it just feeds us what we need to do. How do you do that? Add another test. So unit tests. The third one, these are the first 2 that we already know. I want to make sure that I'm going to talk to my third party or my provider, which is the rep of that, correctly. So if I pass it, I don't know if when I'm mocking and returning anything can do whatever I want, but I want to make sure that when I talk to my third-party service or my adapter, I talk to it the way I expect it to. It's like if you want to verify a method was called. This is exactly what I'm going to do. So what does this test look like? Well, if I'm setting a start point in New York and a destination to Los Angeles, how do I know things are going to be okay? That means that the get distance method on the provider is going to be called with starting point and destination. If I do this, then I'm calling it correctly. Obviously, this fails right now because set destination doesn't do anything. And it gets called with starting point and starting point. Remember? And you can see that in the log that it doesn't have the same objects, which is cool because we're going to fix that. So we're going to pass the unit test. How are we going to do that? Fix the navigator. So now we're serving the destination and passing it here. Excellent. We have 3 passing unit tests. So at this point, I'm going to stop developing the navigator, and I want to make sure the APIs are working. So far, I haven't done anything to do that. So my next step would be to fill the controller. So controller, if you recall, until now looks like this. It has routes, nothing else. Need to add some code in it. And this code needs to call the navigator. So I haven't touched anything yet, not the unit tests. They are working, not the API tests. They are not working, but I'm going to fill the controller in. So next piece of code going in here. And basically what I'm doing is this. I'm getting the content from the request from Flask, and I'm reading the city from a location. Remember, location looks like this. Basically, it doesn't have anything outside of a city, but once I have the value of the city, I can set a destination with it. So it's going to be a location with that city. Start point. Well, at the start point, remember, we said we are going to initialize the navigator with start point. So we're going to get the content. Again, do the location initialization with it. And we're going to have a distance adapter. And we're going to create a navigator with the start location and the distance provider. Finally, the distance part, we're going to call the get distance from destination on our navigator. Basically, we're feeding the navigator and extracting data from it. Excellent. Does it work? Fortunately, no. If I run it, you'll see that both tests are still failing. Since you probably know a lot more about Python than I do, you probably notice, and you're shouting at the screen, why is he using this here? And assume that this will be here. So first of all, Flask test container creates every API call, resets it. We can't really rely on the navigator to be initialized. But more than that, if you're developing APIs, what makes you think, or me assume, that actually set start point is going to really be called before set destination? It's going to be a separate destination. What happens if somebody calls it before that? So I can't do that. I need to change the navigator to assume there is no starting point, which is, if you recall, it's going to be step 1, really, when I thought, well, we'll create something without the starting point. And I'm not going to go through the entire thing again, but I'm going to do this with a couple of small steps, which is modifying the unit tests and modifying the navigator. So unit test now looks like this. Navigator only get a distance provider in the constructor, and then a set start point method. And I'm jumping a bit here, although these are very small steps. So I change the test and then change the code. So now I have still, the unit tests are still passing. And I have to refactor the controller because now navigator looks a bit different. So I need to change the code. First of all, I'm initializing the navigator with the distance provider up here. And then it's the same navigator here, which is very cool. Does it work? Let's run the tests. Remember, we have two tests, right? But only one of them is passing. This passes, that's okay. But if we look at the second one, we'll check why is it still failing. Well, currently at this point, I'm not talking to a real service. So obviously setting the distance to destination and drive to doesn't do anything, right? So I needed to, at this point, to pass these tests, mock the distance provided at the end. So in order to do that, basically what I'm doing is at the setup, get a test client, and I'm patching the distance provider, and I created two methods called, where is it? Set distance to kind of like the what we did unit tests, and set the distances to, which means first return 2500, then 1400. Where is it? Here. Okay, it's a mocking thing. And at this point, let's see if the tests are running. Yes, I have two APIs running. And at this point, I'm going to stop and go back to our slides, because at this point, you probably looking at me or the code very crazily, like this. What do you want from me? Where are we? So I'm going to summarize what happens. Okay, what we got until now. We're jumping on into all this through all these very small steps. So what have we got? First of all, we have API tests that are passing, and we have unit tests that are passing. Good. That means the functionality works. Second thing, we have readable API tests. We kind of refactored on the way. We have readable unit tests. Now, I always say that readable means that somebody else read the code, not just I did that, but I'm assuming I have audience here. You read the code as well, so it is readable. We have architecture and logic that work, and that means they can be extended in these kind of steps, because we kept it modularized. Controller is an adapter, it just feeds the navigator. Most of the logic in the navigator and the distance, which is part of the domain logic. And we're going to talk to different service through the adapter. And the main workflows do work. What is missing though? Because obviously we haven't done everything. So what we still need to do just to make this thing actually work. So a couple of things. First of all, the exception thing. Remember the first thing that we showed, it could be that we call the navigator without a starting point. We need to handle this in some way. We might select not to do that. Said that there's no way somebody's going to do that. And it might be like a good decision to do. I don't know, but this is something that still makes sense to think about. Second thing is integrate the real distance provider, right? We want to see that it actually works with a third-party service. So we need to implement not just for the tests, but also for the application to create initialization of this provider. And this is something I didn't go into, but I might want to use dependency injection here, inject it differently in application mode, in production mode, rather than testing. So obviously the integration with the real distance provider, the real service, and like I said before, I'm in the beginning. Remember, we wanted to extend the test that we have to give us more confidence. I might want to write more integrated tests with the service. We don't have a lot of time, so I want to summarize what we did until now and the principles that we went through, because this is basically the principle that we need to keep in mind as we're doing that. The first thing to do is, like I showed you, even nauseatically, very, very small steps. I did very small steps, and what you saw here, and you can look at the commit list, everything, every step, not even a test passing. And I decided this is a step, I commit. I can squash them later, I can do whatever I want, but these very small steps have very big value to me. I can, if there's a problem, throwing them away is not a problem, not something that sunk cost that I'll be feeling bad about, because these are like minutes or I don't know, half an hour of work. That's okay. And it leads me on the way, and I can change directions on the way because these are not big changes. So small steps are very, very important. Final thing, not final, one more thing. Think about where you're going and focus on that thing only. Not like Mr. Ronaldo here. Every step had a focus. I said, this is what I'm going to do. If it didn't work, I changed direction, but I worked only on that thing and that thing only. So focus is very important because this is how we get to the next steps after that. Other thing, I told you before, it's going to be like a dance, like you move forward, you move backward. It's okay, because this is how we never build software like from one point to another. We get back, we learn something, we kind of think about it, we change direction. And with small steps, changing the direction is not expensive. And this is very important to understand. When you start working like that, you kind of get addicted to that. So can it work in the real world? Yes, I actually did that multiple times with my clients. And the same thinking, small steps, focus on them, passing the tests, creating the APIs, creating extended API tests to prove things are working, actually works. And basically, this is what I wanted to show and share with you today. So if you have questions, I'm ready to answer them, and you can get in touch with me with whatever way you see on the screen right now, which I think almost covers everything in the known galaxy. Other than that, thank you very much for being here and listening and not throwing mud at me. Thank you very much.